Okay, we're going to take a look at a very important flip. We will just call that the flip. It is applied to the xy plane diagonally, diagonally meaning along the line y equals x. So let's take a look at what that flip is going to do. Okay, so so we have here this clear plastic transparency sheet. It says down here, graph of f the original. There's a hold written in the upper right corner and in the lower left corner. If we hold it here and there, we flip diagonally, it looks like that. And then we're just going to unflip this back this way. Again, so it says graph of f, comma, the original. And then when we do the flip, there's this text down here that says graph of, it looks like f to the -1, comma, the inverse, and actually back in the original setting, that text is kind of backwards, sort of sideways here. Now, what I'd like to do is predict what happens after the flip. So I've moved the transparent sheet, you'll see, let's say back here, back to its original setup. But if we apply the flip, then where's the x-axis going to be? Now, I would strongly suggest you draw your own conjecture on paper first. Okay, so take a look at this x-axis right here. Where is this going to end up? What we'll actually do, because it'll be a little more helpful to see, is let's just circle that x-axis right there. Now, if we apply the diagonal flip, it ends up becoming horizontal. Okay, let's try something like this again. So bringing the transparency back to the pre-flip situation, we'll draw the point x comma y equals 10 comma -1, which is mostly east and slightly south. And then after the flip, where will the point end up? It'll be helpful to draw your own picture, make a conjecture, predict what happens, think about this actively. You may find it useful to use words like mostly or slightly, as well as words like north, south, east, or west. So let's take a look over here. Okay, we want the point 10 comma -1, so moving far off to the right and then slightly down. So there's a point right there, and then let's try to draw that point as visible as possible. And we take this, and we're about to do the diagonal flip. Where's that point going to end up? Try to draw your own prediction of this. Right now, the point is mostly east and slightly south. Okay, what happens after the flip? Did you draw your own picture? The point ends up mostly north, you'll see right over there. Mostly north and slightly west. I mean, that point would be like -1 comma +10. Okay, we're going to draw the graph of f of x equals x squared on the transparency, and then answer the questions. Before flipping, does the vertical line test pass? And after flipping, does the vertical line test pass? So there's f of x equals x squared, standard parabola. Before flipping, does the vertical line test pass? Sure. Everywhere we think of drawing a vertical line, the vertical line only goes to the parabola in one location. After flipping diagonally, does the vertical line test pass? And we see that after flipping, the vertical line test definitely does not pass. For instance, that vertical line there causes a problem. Okay, now in the pre-flip setting, we're going to draw a horizontal line. After the flip, what do you predict will occur? What should we see? So a horizontal line pre-flip, that horizontal line could be this horizontal line, or it could be a horizontal line down here, it doesn't matter. But after drawing let's just only use one of these. So after drawing a horizontal line, okay, we're going to now do the flip in just a moment. What's going to happen? What's going to happen with that line? What's it going to look like? We're starting with this horizontal line that's above the x-axis. After this diagonal flip, we end up with a vertical line. We actually already saw this phenomenon with a different horizontal line earlier. We saw it with just the x-axis alone.